Today we do talk more about logs. We've done some extremely simple log equations so far. Today we're going to get ones that are a little bit more complicated. Instead of just having one log in there and converting it to exponential form or something, we're going to talk, what about if we have log plus log equals some log? How can we combine all of those and get it back to the kind of problem we know how to solve and we know what to do with? So there will be three formulas that we add to our formula list, and those all come from our rules for working with exponents. Remember, we said the log is the exponent. So we know if we have something like this, x squared times x cubed, we need to add the exponents. If the log is the exponent, this means we are adding the logs because we are adding the exponents. So if we have two logs that we are adding, that came from multiplying the whole original argument. So we know that if we have the log of 5 plus the log of 7, we can combine those as just one log if we take these two arguments and multiply them. The 35 comes from 5 times 7. This works as long as the base is the same all the way across. I can't have one of them as a log 2, one's a log 3, and one's a log 5 or something. If they're all log 10, it works. Or if they're all log 3, it works. Or if they are all log 7, it works. But it does not work if you've got two or three different bases running around in there. Okay, we have another property that we know how to use with exponents. We know if we have something like this, we need to subtract the exponents. The log is the exponent, so this means if we are subtracting the exponents, we're subtracting the logs. So if we are subtracting the logs, that means we had to take those arguments and divide them. So if I have something, my bases are the same all the way across, this time it's 3 all the way across, I am subtracting the logs, so I need to divide the arguments. The 14 over the 7 is how I get the 2. The order matters when we are subtracting, because if I started with the log 3 and put the minus sign in front of the log 14, whichever one has the minus has to go in the denominator. So this would have been the 7 divided by the 14 is how we get the 1/2. And the last one, we know we can do power of a power. We know there are times when we multiply our exponents together. So we would be, if we are, in that case, what we would be doing, if we are taking one of the exponents and we're multiplying that by the constant of 4, that means that this original argument was raised to that power. So if I have 4 log 100, I can take that 4 from out in front and bring it over here as an exponent on my argument so that I have 100 to the 4th power. And I've got the log base 5 of that. I could do it sometimes with a variable in there as well. If I have an x out in front, I can bring that in as an exponent. So now I have log base 5 of 100 to the x. It also means I could go the other way. If I started with something like this, I could take the x and put it out in front and have what I have over on the left side of that equation. So let's put these 3 into your formula page. And I don't like the way this typeface showed up on that one, so I'm going to rewrite that one as the log base b of the m raised to the x power. The typeface that was printed looked almost like an m times x. It just looked kind of confusing to me. And I want you to remember that every single one of these goes both ways. If I have one log plus another log with the same base, I can combine those or condense those as log base b mn. Or if I start with log base b of two things that are multiplied or that I can factor, I can expand that as log base b of one of them plus log base b of the other one. Same thing with the second one. If I start out and I'm subtracting two logs with the same bases, I can condense that, just one single log, and the m over the n. I divide those arguments. Or if I start off with the log base b of some kind of a quotient, I can take the log of the numerator minus the log of the denominator when I expand that out. This one, I can take the x and bring it in as an exponent on the m, or I can start with log base b of some argument that's raised to a power, and in that case, I can bring the exponent out in front. So it looks like we're pretty close to having those all written down. We're almost ready to do some examples. But one other thing I want to point out, at this point, we are trying to get an actually right log base b of something equals log base b of something else. If I have two logs on one side, I can't go on to the next step of solving the equation. I have to figure out how to put them together as just one log. I require that you write this down. Log of equals log of. Even if you're thinking ahead the next step mental math, I want to see that written down. Because in a lesson coming up pretty soon, we're going to have log of something on one side equals, and the other side will not have a log on it. And if you don't get yourself in the habit of writing what it is condensed first, you're going to mess all of those up. So every single one, I want to see the step log equals log. This may be something kind of messy. I may have things that are multiplied or divided in here, but I've got to get it where it's just one log. Does that make sense to everybody? So if I have something like this where it's log 7 of something equals log 7, once I get it like that, if the bases are the same, I can simply say that means the arguments have to be equal, x equals y. That's why it's going to help me to get to that step, because I can get the logs out of there and get something I can solve. If you prefer, once you are at this step, log equals log, you may write each side as an exponent on the same base. So if this was a base 7, I can say I'm going to make that whole first side be an exponent for 7, and I'm going to make the whole right side be an exponent for 7. So I'm exponentiating both sides. So those cancel, and I have x equals y that way. Next one's a little bit messier, but I have log 5 equals log 5, right? So that means that my arguments have to be equal. And if you prefer, and don't tune me out on this, and I'll explain why in a moment, you could say, oh, both of them are base 5. So if I write the left side as an exponent of 5 and the right side is an exponent of 5, this will cancel and I'll have x plus 1. And this will cancel and I'll just have 7. You may want to start thinking about it that way, because when we have those problems I was just talking about where I've got log on the left but no log on the right, I don't have two arguments I can set equal. I have one argument. So then I'm going to have to exponentiate both sides to get the correct second side on that. That's why I'm starting to say it both ways. So you start getting used to hearing it both ways. Okay, so shout out, what is x for this one? Easy enough? Okay, let's try this one. I have a bunch of logs. Do they all have the same base? So I'm going to try to put some things together. So the right side is only one log, But the left side is a log plus a log, and I need to get it to where there's just one log over there. So look at your formula list. If I have log plus log, what do I have to do with those arguments if I want to condense this, Abby? I need to multiply them, so I'm going to take the 4 times the x plus 8 and have those multiplied together. So now I have log base 5 equals log base 5. So 1 log equals that same kind of log. I could exponentiate both sides, which means my arguments are equal. So I'd have the 4x plus 32 when I multiply that argument equals 80. Give me a thumbs up if you're comfortable with getting to that step. Okay, you guys finish solving it. So if we subtract 32 on both sides, we have 48 is 4x. Divide both sides by 4. And I agree with what you guys just said, that x is 12. Now I want us to start getting in the habit of, we need to check our answers on log equations. I don't care if x is positive, negative, or 0. I care about my original arguments. I'm not going to look here because that's after I've done a step of math. Look back at what is printed in the book or on the test, and any of them that have an x in it. Say, well, if that x is 12, the argument isn't 12, the argument's 12 plus 8. Is 12 plus 8 positive? So that is good. That's what I want. I'm happy with that. I can keep x equals 12 as an answer. Anybody with a question on that one? Okay, just 2 more. We can do this. 2 more, and then you'll be working on homework. So this one, log minus log equals log. I've got too many logs in there. Are they all the same base? So for the side with 2 of them, I need to put those together so it is log equals log. This time I have a minus sign in there. And when I have a minus sign, what do I need to do with those 2 arguments? I need to divide. The one with the minus in front of it needs to go in the denominator. The one with a plus in front of it needs to go in the numerator. Now I have log 7 of something equals log 7 of something. Now we say that the arguments are equal. So now we have x plus 7 over x minus 2 equals 10. What should we do as our next step in this? Austin? But what's my next step to get there? I think you're on the right track. I'm having a little bit of trouble hearing what you're saying. Somebody who could hear better want to explain what do we need to do at this point, Abby? Okay, multiply both sides by x minus 2 or take the cross product. Whichever way you want to think about it. Solve it just like you guys did the last one. We're going to take the 10 times the x minus 2, and that's going to equal the x plus 7. And you guys are going to come up with this answer for me. Hopefully we are almost there. Everybody shout out what you get. I heard an awful lot of 3s. Let's see if I can get a 3 out of it. 10x minus 20 is x plus 7. Subtract the x on both sides, so we have 9x. Add 20 to both sides is 27. And yes, I agree with you, x is 3. Once again, we want to get in the habit of going back to the very original printed equation and make sure that that will work. If I put a 3 in for every x I see, will 3 plus 7 be positive? Will 3 minus 2 be positive? So that means I can keep x equals 3 as my answer. Okay, we use 2 of those 3 log properties that you wrote down on your formula list. So we need one more example so we can have an illustration of that last one. 2 log 3x equals log 316. This does not say log 3 equals log 3. It says 2 log 3 equals log. We can't set arguments equal yet. It's got to be just log equals log. Who remembers or can look at your list? What can I do with this 2, Madeline? I divide when I have log minus log. Look at the formula list if that will help. What do we do when we have a number out in front? Where can we move that number that was out in front of the log? You don't get to do all the work for the whole class, but thank you. Somebody else. Cooper, what can I do with a 2? I can make it be a square, so now that argument would be x squared. So I've got log base 3 of x squared is log base 3 of 16. Log 3 equals log 3. Arguments are equal. X squared is 16. What 2 answers can I have for x? Wyatt? Plus or minus 4. And again, I don't care if x is positive, negative, or 0. All of those work in some log problems. What we have to check is to go back to the original printed one and make sure that all of our arguments are positive. So I'm going to erase this so it's easy to see what my original argument was. So I find all of the x's in this thing. And if I put a 4 in there, I'm okay. But if I put a negative 4 right there, then that argument is negative. So I have to throw away the negative one. And my final answer is only x equals 4. Have any questions on this? And we'll get some homework done.